Day 787 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2656, maximum sum with exactly k elements. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a zero-index integer array nums and an integer k. Your task is to perform the following operation exactly k times in order to maximize your score. Select an element m from nums, remove the selected element m from the array, add a new element with the value of m plus 1 to the array, increase your score by m. Return the maximum score you can achieve after performing the operation exactly k times. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input nums equals an array of integers 1, 2, 3, 4, 5. The output, and k equals 3. That means we need to perform these operations 3 times. Boom. And then it says the output is 18. So first, let me copy and paste this over here for our handy dandy visual representation. Now let's go through the explanation. It says we need to choose exactly 3 elements from nums to maximize the sum. That 3 comes from k right here. Boom. It says for the first iteration, we choose 5, then the sum is 5. So we're going to choose this 5. We're going to select an element n from nums. So we're going to select 5. Boom. We're going to remove the element n from nums from the array. So let's remove it. Boom. Then we're going to add a new element with the value of n plus 1 to the array. So 5 plus 1 is 6. Boom. Then we're going to increase our score by m. So let's put the score down here. M was 5. So we're going to put 5 right here. Boom. Then it says for the second iteration, we choose 6, and the sum is 5 plus 6. So we're going to do it again. Once again, we're going to select an element from nums. We're going to select this 6. Boom. Hold on. We're going to select the 6. Boom. Then we need to remove m from nums. So let's remove that 6. Boom. Then we need to add a new element with m plus 1. So 6 plus 1 is 7. Boom. Then we need to increase our score by m. So we'll say plus 6. Boom. But we're not done yet. It says because we need to do it 3 times. So it says for right here, for the third iteration, we choose 7. The sum would be 5 plus 6 plus 7. Boom. So one more time, we're going to choose m. This time, we're going to choose 7. Boom. We're going to remove it. Boom. We're going to add new one. But we don't, we can't add it. We don't really need to because we're done, but we'll add it just in case. And we put add 7 to our score. We add 5 plus 6 plus 7. That gives us 18, y'all, and boom. That's how we got our output of 18. So just in case that didn't make sense, y'all, let's go ahead and take a look at example 2. So in example 2, our input nums equals an array of integers 5, 5, 5. This time k equals 2, so we only need to perform the operation 2 times. So let me go ahead and copy and paste this over here. One moment. Boom. Now let's go through it. It says the output is 11. It says we need to choose exactly 2 elements from nums to maximize the sum. So it says for the first iteration, we choose 5. The sum is 5, and nums is equal to 5, 5, 6. So let's go ahead, go through it. We're going to select 5. We're going to change it to 6, which is n plus 1. Then hold on, our score. Right now, our score is 5. Boom. Now we need to do it one more time. It says for the second iteration, we choose 6. The sum is 5 plus 6, which equals 11. So this time, we can change this 6 to 7, but we're done. 5 plus 6 equals 11. Boom, y'all. It says it can be proven that 11 is the maximum answer that we can achieve. So, boom. I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we need to do is we're going to sort the array in descending order so the largest element appears at index 0. So we're going to say let sorted nums equal nums dot sorted, open up the parentheses, we're going to say by colon, put a greater than sign. Boom. Now we're going to start with the largest number in the array. This is always the optimal choice for the first operation. So we'll come underneath this, declare a variable called max element. We'll set that equal to sorted nums, square bracket 0. Boom. Now we need to store the total score accumulated over k operations. So we'll come underneath this, declare a variable called sum, set that equal to 0. Now we're going to perform exactly k operations. So we'll say 4 underscore and 0 dot dot less than k. We'll open under brackets and we'll add the current largest available value to the score. So we'll say sum plus equals max element. Boom. Now, after choosing a number, the problem allows us to increase it by 1 and put it back into the array. Since we're always picking the current maximum, the sequence of chosen values becomes max, max plus 1, max plus 2, so on, so on. So we simply increase the element, we simply increment max element for the next iteration by coming right here, and we're going to say max element plus equals 1. Boom. Now we need to return the maximum possible score after k operations by coming right here, and we could just say return sum, y'all. Boom. That's all she wrote. Let's go ahead and give it a run. Make sure it runs properly before we submit it. It's accepted, so let's go ahead and submit it. Let's see. And look at that, y'all. 3 milliseconds beats 22.22% of users. Not too bad at all, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.